This is CS50, and this is a very exciting day because today we're going to learn a new language, and that's not something that you can say happens to you every day. And this language is going to look a little something like this. Today we introduce C, a very traditional, a very old language that's purely text-based, but it can do everything that you can do in Scratch and even more, but without the user-friendliness that we're now used to over the past few days. However, even though this might look quite cryptic to you at first glance, even though there's some English or English-like words in there, rest assured that within a few days, certainly within a few weeks, you'll be able to understand every character on the screen, every line of code, and much more. But I dare say that any course like this can be a little daunting, especially if you have no prior experience. But recall from last week, that is indeed the norm, the common case. 2/3 of CS50 students, perhaps yourself among them, have never taken a CS course before. So what looks like this today, realize will feel exactly like this ultimately. Indeed, even though the code is going to look different, even though the code is going to look different, the ideas today are going to be absolutely the same as this past week in Scratch. We'll look at functions and conditions and Boolean expressions, loops, and other features along the way. But I'm perhaps reminded of this wonderful hack from MIT back in 1991. An expression at MIT is that getting an education from MIT is like taking a drink from a fire hose. And in the spirit of MIT hacks, as they're called, some students wired up an actual fire hose to an actual water fountain with a sign on the wall that says exactly that. And this is the kind of course, as with many introductory courses, where it feels like you're really getting hit in the face with way more information, way more ideas than you can possibly take down all at once. But realize that you'll be able to absorb all the more material over time. And the goal of the class ultimately is to present you with as many concepts and practical skills as might prove useful later on. And so realize by end of semester, will this feel much less like this and much more like something you have succeeded at. So without further ado, let's go about introducing this language called C. So on the left here, recall that this was maybe the simplest program we could write in Scratch. And all this program did was compel a cat or any sprite to say hello on the screen. Today, to achieve that same result, we're going to start writing code that looks like this, using a keyboard only, fewer graphical user controls. But let's see why the left is actually equivalent to the right. So let's break it down into, say, this single puzzle piece. This, of course, did what? This represented what in the context of a Scratch program? What was the role of this puzzle piece? Yeah, for starting things. So for the main part of your program to kick off, you have to attach it to this when green flag clicked puzzle piece. And we're going to see in C that it's not nearly as straightforward, but it's something that you can just kind of copy paste for now. And within a few days, will this make more sense character by character? Int main void, and then this open curly brace, as it's called, followed by this closed curly brace, suggests that all of the code that we're going to write today onward is going to go between those two curly braces, as opposed to underneath a puzzle piece like this. So even though this won't make perfect sense today or for a few days, realize that it is functionally equivalent to just saying when the green flag is clicked, here is the main part of my program. Now, what might a program actually do for you? Well, you might have something like say hello world in Scratch that just literally prints that on the screen. So let's consider how you would implement this in C, C being a text-based or keyboard-based language. Well, there isn't a verb or a function called say in C. Instead, it's called print, or not quite print. It's actually called printf, where the F stands for formatted, so that you can print formatted text, as we'll soon see. Then you go ahead and put next to printf two parentheses, an open parenthesis and a closed parenthesis. And that's kind of reminiscent of this oval shape in which we were previously putting input into in the first place. And the input we provided last week was to just say hello world. So I'm literally in C going to write hello world in between those two parentheses. But C is a little more nitpicky. You can't just start writing words in between parentheses. Anytime you have characters or words or sentences or phrases, you need to actually encapsulate that text with double quotes, as in this case. So you just have to surround whatever it is you want to say or print with double quotes here. And the last thing with C that's so easy to forget early on, as you undoubtedly will, is that you need to finish your thought. So just like in an English essay, you typically end a sentence with a period. So in C, do you finish your thought, but not with a period, but with a semicolon, generally at the end of a line of code, but we'll see which types of lines of code require this. So on the left, we have an idea from last week. On the right, we have an idea from this week, as we'll soon see on my computer, but they are functionally equivalent. They do the same thing. So how do we go about then getting from this Scratch program to this Scratch program? Let's go ahead and point one last thing. We need one last line of code, which I just popped up on the screen, which is to include standard io.h. Well, what does that mean? It turns out that Scratch is super user-friendly. You've got all of those colorful categories of puzzle pieces on the left, and they're just available to you right from the moment you start using Scratch. In C, when you want to use some function or some puzzle piece, if you will, you have to typically tell the computer in advance where that function is implemented, where it was saved. And this is going to be the admittedly cryptic syntax for saying, hey, computer, look in a file that we're going to start calling standard.io.h, whatever that means, in order to access this function. So again, that's a huge mouthful. That's the first of the fire hoses today. But the important line of code for today's purposes really is going to be this one down in the middle. So how then do I go about writing my very first program in C, just as last week we wrote our very first program in Scratch? Well, consider that the first thing we did in Scratch was to open up a program, a tool, scratch.mit.edu. You can program actually on your own Mac, on your own PC, no matter what operating system you're running. But frankly, it tends to be really annoying and very prone to technical support headaches if all of us try to install requisite software on all of our individual Macs and PCs. Invariably, all of us have different versions of things, and our computers don't quite function the same. So in the earliest weeks of CS50, we use a cloud-based tool, CS50 Sandbox, which lives at sandbox.cs50.io, and you'll use this for your first problem set this coming week. This is a programming environment similar in spirit to Scratch, but that does not use Scratch. It doesn't use puzzle pieces. It instead uses C, this text-based language that we're starting to see now. So there's two main parts to this programming environment. On the top here is just going to be where I write my actual code. Literally in a moment, I'm going to click that plus, and I'm going to create a new file, and I'm going to start writing code in that file and save it. And then in the bottom half of this programming environment, it's what we're going to start calling a terminal window. A terminal window is sort of an old school interface via which you can run commands by literally typing them at a prompt and then hitting enter. So unlike in Scratch, and frankly, unlike in macOS and Windows these days, where you point and click and drag and so forth, interacting with a graphical user interface, a lot of our programming early on is going to involve typing commands. So let's make this more real. The goal at hand, again, is to quite simply implement a program in C that says hello to the world, which is functionally going to be similar to the Scratch program at left, but we now need to implement it using the language at right. So in this programming environment, I'm going to go ahead and click this plus sign up top for new file or tab. By convention, I'm going to go ahead and name my file something like hello.c. Hello, just because I want this program to say hello, but I could call it anything I want. And .c, because the convention in this programming language C is to name your files that contain your code with literally .c, much like you have .doc or .x for Microsoft Word, .gif for graphical files, and the like. So I'm going to go ahead and click Create File, and you'll see now that I have a blinking prompt on line 1. It's going to automatically number my lines for me in a tab called hello.c. This is where I can write code. Now, even though the code I'm about to write is frankly pretty cryptic, include standard.io, int, main, void, and then in here I'm going to do printf, quote unquote, hello world, semicolon. I have just written my first program in C. So I'm going to go ahead and zoom in at top left. It's 6 lines of code total. And you'll see that I have include standard.io.h, whatever that means, int main void, whatever that means. And then really the essence of this program is on line 5, print, or printf for formatting, hello world. So recall that int main void is similar in spirit to the when green flag clicked, and printf is similar to the say block. And this top line of code, we just need it because the computer is not going to understand printf unless I tell it to include that file. All right, so now I claim I've written some code. How do I go about running it? Well, how do you run a program on your Mac or PC? What do you typically do? You double click it, right? And unfortunately, there doesn't seem to be anything obvious to double click here. In fact, there's no icon on my screen. And in fact, there's no program per se yet because computers, recall from last week, don't understand English. They don't technically understand C per se. What is the language that computers speak and understand? Yeah, so binary, zeros and ones. And yet this clearly is not zeros and ones. And frankly, none of us would have a good time if coding involved these days literally writing zeros and ones, which in some sense it did involve way back in the day. But nowadays, it turns out there's a solution to this problem. This, as cryptic as it looks to most of us in this room, at least you can imagine eventually getting comfortable probably with this syntax once you learn the rules and the syntax and so forth. But we need to convert it somehow to zeros and ones, and how to do that is perhaps non-obvious. So it turns out if we want to convert code like this to zeros and ones that the computer understands, there needs to be some intermediate step. I actually need, on my Mac or PC or this cloud-based environment, a program that is going to take as input my source code, which is that language called C, and is going to produce as output what's called machine code. So source code is something like C or Python or Java or C++ and maybe other languages you've heard about. It's English-like syntax in which you write programs. Machine code is the zeros and ones that every computer actually understands. So to get from source code to machine code, there needs to be some kind of algorithm, or more specifically, a piece of software that does that conversion, and that piece of software is what we're going to start calling a compiler. So we're going to write code literally by just typing commands at a keyboard. We're going to save those commands in a file, just like you saved your code in Scratch. But before I can run my program and do the equivalent of double-clicking on it, I need to run it through a compiler and produce output, which is zeros and ones. So how do I go about doing that? This is the first of the more esoteric commands, but it turns out it's relatively straightforward to do. At the top of my programming environment, again, I have my code here at top left. And if I scroll down to the bottom, I have this, again, so-called terminal window. And the $ is just a weird human convention. The $ just means type something here. That's your so-called prompt or your shell. But the blinking cursor is just inviting me to type a command at this prompt. The first command I'm going to type is what's called clang for C language. Clang is the name of a program that exists to compile code. Someone else wrote this. Someone else online built this program called Clang. A whole group of people, in fact, made it freely available for me and you to download onto your own Macs or PCs or this sandbox environment. And we can use Clang to convert source code to machine code. So I'm going to go ahead and run clang hello.c. I've not hit enter yet, but the moment I hit enter, we're going to see something happen. Let me go up to this little folder icon up here, and you can actually see all of the files in my current sandbox, so to speak, my programming environment. There's, of course, only one, because the only file I've created thus far is called hello.c. But notice what happens the moment I hit enter after having typed out clang hello.c. So clearly something else exists now, and it's a really stupid name and very cryptic. It's a.out. But you can perhaps guess what's inside of that new file. What might be inside of it? Yeah, machine code. So it stands for assembly output, but that just means machine code. So inside of this file are a whole bunch of zeros and ones that correspond to this code, but in binary, in the language the computer can understand. So literally what I just did was this. I took as input code that looks like this, written in C. I ran it as input into the compiler and produced this output, zeros and ones, and those zeros and ones were automatically saved for me inside of a file that by human convention is called a.out. All right, but someone proposed earlier to run a program typically on your Mac and PC, you just double click it. But there's really nothing to double click, and in fact, if I double click on this, it's going to look really weird and the computer's not going to understand it because it's zeros and ones that aren't meant to be clicked, they're meant to be executed at this command prompt. So let me go ahead and do this. This too is cryptic, but I'm going to go ahead and do /a.out, and this, weird as this may look at first glance, is how I tell the computer, run the program a.out in my current directory. So that period that I typed first just means it's literally right here in my current folder, as though you're double-clicking on it on your Mac or PC. And /a.out means look in this directory and run the program in the file called a.out. So let me go ahead and hit enter now. And voila, hello world. So you were very impressed last week, as I recall, when I made the cat say hello world. Here, we seem less than underwhelmed, but hello world is now my program in C that's done exactly the same thing, but admittedly, it looks a little stupid at the moment. It looks a little buggy. What rubs you the wrong way, even if you've never programmed before? Yeah, the $, like I didn't mean to say hello world $, but that $, is just like an artifact, right? What is the $, again? It's just that prompt. It's waiting for another command, and that's why my cursor is blinking there, but it just looks stupid, right? We could argue that this was my intent, but frankly, I'd be lying. That doesn't quite do what I want it to do. And this is because, unlike Scratch, which again is more user-friendly, C, and many languages like it, literally will only do what you tell them to do. At no point did I tell the computer to move the cursor to a new line. I didn't finish that thought. I said hello, comma, world, and that's it. I never sent a command to the computer to actually move that cursor, but I can. So let me go back up to my code here, and it turns out that in C, if you tell the computer to print hello, comma, world, that is literally all it's going to print for you. If you want to print a new line, you need to use a special command, a special character called a new line character, which is represented by \n. Now, why is that? Well, it's really because even though you might be inclined to hit enter like this and just hit enter like you would hope the computer would do, even if you've never programmed before, this probably should start to rub you in the wrong way. It just looks a little weird. It looks a little messy that one line is up here and the second line is down here. So what humans decided years ago is let's just have a simple instruction, \n, that tells the computer to move that new line down. So let me go ahead and zoom out now. In the sandbox, it automatically saves like Google Docs. So you don't have to go to File, Save, or anything like that. If I go ahead now and rerun this program, /a.out, enter, it's not yet fixed. Let me go ahead and zoom in. Notice that the symptom is still there. Why? What mistake have I already made? Yeah, I didn't recompile it. So again, the computer is going to start taking you very, very literally now that you're programming it to do things. And if you want to run the new version of your code, you are literally going to have to do something like clang and then hello.c enter. And nothing seems to happen. And frankly, and ironically, when you don't see any output, that usually is a good thing. When you do see output, it's usually a list of like 5 mistakes that you made or error messages that we'll soon see. But we still have a.out. It's just a newer version thereof. So if I go ahead and zoom in now and do this, /a.out, enter, now I have a more impressive version of hello world. I've just cleaned it up a little bit. All right, let me pause for just a moment and see if there are any questions on these mechanics thus far. Yeah. What, say a little louder. Why is line 2 empty? Oh, really good question. So line 2 is empty just because I have decided stylistically it looks a little better. Much like in an English essay, you might hit enter, enter to just separate your paragraphs. So we'll